Ever look up at the night sky and imagine all the stories unfolding in that endless expanse? That's what makes space news so captivating. Even the most ordinary-seeming missions can surprise us with stunning images, new insights, and dramatic rescues. Today, we're diving into a variety of discoveries and events. From a passing probe catching a glimpse of a Martian moon, to potential mini-lightning sparking life on Earth. Each development sheds more light on our universe, reminding us that the boundaries of the unknown keep stretching wider. As you listen, picture yourself on a cosmic journey, drifting from Mars to distant supernovae, then back to Earth's friendly glow. There's always more waiting to be uncovered, and each fresh revelation feels like a special invitation to dig deeper into the grand story of existence. A spacecraft designed to study an asteroid took a detour by the Red Planet, snapping rare pictures of one of Mars's elusive moons. It was an unexpected photo op. Think of it like grabbing a quick selfie during a layover on a long journey. These images revealed fresh details on the moon's cracked surface, raising all sorts of questions about its true origin. Some scientists believe it might be a stray asteroid Mars captured in its gravitational field. Others suspect it formed from a colossal impact eons ago. The mission team never intended to photograph this moon, making their discovery a delightful bonus. It's a reminder that space travel often comes with surprises, and a big part of exploration is staying open to whatever cosmic secrets might pop up along the way. Even brief encounters can yield insights that fuel deeper research. Meanwhile, researchers mapping cosmic shear have found more clues about dark energy, the mysterious force that speeds up the expansion of our universe. You can imagine cosmic shear like a barely perceptible distortion of distant galaxy light, caused by colossal amounts of hidden mass-bending space itself. It's essentially a galactic funhouse mirror. But instead of playful illusions, the distortions could help us understand why galaxies are accelerating away from each other. Every subtle shift in these images serves as a measurement of how matter clusters across cosmic scales. Think of it like reading the ripples on a vast pond to figure out how deep the water is, and what might be lurking beneath. The data is painstakingly collected and refined, offering incremental but vital hints about the nature of dark energy, and bit by bit, scientists are hoping to illuminate one of astronomy's biggest enigmas. On a more unsettling note, research suggests violent supernovae might have led to at least 2 mass extinction events here on Earth. Picture an exploding star far beyond our solar system, hurling energetic particles and radiation across interstellar distances until they finally reach our planet. While Earth's magnetic field and atmosphere do a decent job shielding us from cosmic threats, a sufficiently close supernova could destabilize the ozone layer, letting harmful radiation pour in. Over eons, our planet's geological record holds clues, such as unusual isotopes that point to cosmic origins. It's kind of like a trail of cosmic breadcrumbs. The idea that life's path on Earth can be shaped by detonations light years away adds a dash of cosmic drama to our perspective. Yet it also underscores how interconnected everything is in this vast universe. Even cataclysmic stellar deaths can eventually leave signatures on our own world. Closer to home, there's an ongoing debate about just how wet Mars once was, with new research challenging established viewpoints. Some scientists have long contended that Mars was once a water-rich planet sporting lakes or even oceans, but recent data implies that certain mineral layers, once believed to prove widespread water activity, might have formed under relatively arid conditions. It's a bit like re-examining footprints you thought were left by a large animal, only to realize they might have been made by something else entirely. This shift in perspective doesn't eliminate the possibility of ancient Martian water. It just urges a more cautious approach. Each new discovery forces a recalibration of past assumptions. Far from diminishing our excitement, it highlights the lively, iterative nature of scientific inquiry. Sometimes the story changes because we learn to read the clues more accurately. In a more dramatic corner of our galaxy, astronomers have discovered another supergiant fast X-ray transient, expanding a rare class of cosmic phenomena. Think of these events as brilliant but short-lived fireworks. They blaze in X-ray light for a brief period before fading into near obscurity. Typically, such outbursts happen when a neutron star or black hole in a binary system interacts with the wind of a massive star. Observing them demands keen timing, as these flares can appear and vanish in the blink of an eye. Each new transient found broadens our understanding of high-energy physics, shedding light on how enormous stars and their compact companions coexist and sometimes clash. The discovery process itself is part detective work, part cosmic lottery. Only the most vigilant telescopes can catch these fleeting bursts as they unfold. Turning our gaze skyward, we come to a phenomenon more accessible to everyday stargazers, the so-called blood moon that accompanies a total lunar eclipse. Imagine the moon gradually darkening as it enters Earth's shadow, then glowing red thanks to sunlight refracted through our planet's atmosphere. It's a cosmic magic trick that humans have marveled at for generations, once sparking myths and legends about celestial omens. Modern observers might not fear an incoming apocalypse, but the sight can still be goosebump-inducing. Plus, these events offer a surprising amount of scientific value. Astronomers track changes in the moon's tint to gauge Earth's atmospheric conditions, gleaning data about dust levels, pollution, and more. It's a gentle reminder that our little planet and its lunar companion are engaged in an elegant dance, and that we can learn plenty by simply watching. Meanwhile, down on the lunar surface, a new sounder instrument led by the Southwest Research Institute is steadily gathering data beneath the moon's outer layer. Think of it as performing an ultrasound to reveal structures hidden under dusty regolith. Researchers hope to map geological features, discover pockets of water ice, and uncover secrets about the moon's formation history. The environment is unforgiving. Low gravity, sharp temperature shifts, and clingy dust complicate even the simplest maneuvers. Yet each successful deployment marks a step forward for lunar science and potential human habitation. After all, finding usable resources like water ice could be a game changer for explorers aiming to set up shop beyond Earth. The more we learn about our celestial neighbor, the clearer it becomes that its dusty surface hides a wealth of untapped stories. In Earth's orbit, a recent crew launch to the International Space Station has secured a safe ride home for astronauts affected by a damaged spacecraft. When a vehicle destined to return astronauts developed critical issues, it raised the stakes for space agencies worldwide. Fortunately, planning for contingencies is a big part of spaceflight, so a new craft was sent up, ensuring there'd be enough seats for everyone to come back safely. It's a vivid example of how even routine missions can suddenly become urgent rescues, yet the system is designed to handle such crises. Astronauts train extensively for every scenario, knowing that in the vacuum of space, minor glitches can escalate quickly. The successful launch and docking serve as a timely reminder. Behind every seamless mission is a complex network of backup plans, collaboration, and innovative thinking that keeps everyone in orbit secure. Another satellite mission that might seem less flashy has returned data from over 3,000 orbits studying atmospheric waves. These waves, formed by natural forces like storms or mountain ranges, ripple upward to higher altitudes. Monitoring them helps scientists refine models of how energy and weather move through the atmosphere. Imagine taking your planet's pulse thousands of times. You start to notice patterns and anomalies that reveal how climate systems truly work. Over time, these measurements also help predict extreme weather events or track long-term shifts in Earth's protective layers. The engineering effort behind any long-duration satellite is immense. Maintaining stable instrumentation through temperature swings and radiation is no small task. But the payoff is huge. A more intimate understanding of the dynamic processes shaping the air we breathe and the weather we face. Far beyond our solar system, researchers identified TOI 1453c, a sub-Neptune planet in a two-planet system. Sub-Neptunes are a type of world slightly smaller than our own ice giants, yet larger than Earth, often with thick gassy atmospheres. What makes this finding especially exciting is the system's second planet. 2 glimpses into exoplanet diversity orbiting the same star. Astronomers began by spotting slight dips in starlight as these planets passed in front of their sun, a method that might sound simple but requires remarkable precision. Each planet discovered helps refine theories about how solar systems form and evolve. While we don't have anything exactly like a sub-Neptune nearby, they appear common throughout the galaxy, so every new example is another piece in the cosmic jigsaw puzzle, hinting at countless possible worlds, and maybe even habitats, beyond our own. Finally, there's a fresh spin on the mystery of how life began on Earth. Scientists suggest that tiny sparks, or micro-lightning, inside water droplets might have done the trick. This is a more humble version of the dramatic lightning bolts we typically imagine fueling primordial soup experiments. Instead, small electrical charges within colliding droplets may have created just enough energy to assemble the molecules that gave rise to early life. It's like discovering a hidden chef in the kitchen of planetary chemistry, working quietly in the background. The notion expands our view of where and how life could emerge. Even mild everyday phenomena could drive pivotal chemical reactions if conditions are right. The idea reminds us that big changes often start in the smallest places, a theme that resonates across both biology and astronomy. All these stories, from the moon's hidden layers to Mars's elusive water history, are part of a tapestry that underscores human curiosity and grit. While some discoveries challenge old assumptions and others open doors to entire new fields of study, each serves as a stepping stone on our path to understanding. The next big breakthrough might come from a distant exoplanet transit, or an unexpected snapshot of a passing moon. Whatever the case, this continual stream of revelations keeps us engaged, reminding us how much there is to explore beyond our everyday horizons. Thank you for tuning in today, and here's hoping you'll keep looking up, keep asking questions, and stay ready for the next cosmic surprise. After all, in the boundless playground of space, we've only just begun to scratch the surface.